In this video, we're going to look at how to solve quadratic equations using the method of completing the square. So here I have my first question. We're going to write this quadratic x squared take away 10x plus 25 in the form x plus h squared plus k. So this will be completing the square, taking this quadratic and completing the square. Then for part B, we have hence solve x squared take away 10x plus 25 is equal to 0. So let's start with part A. So in a previous video, I would have shown you how to complete the square. So I'm going to open my brackets. I'm going to put my square sign. My variable is x. I'm going to write that. We have this negative 10 here, and I'm going to find half of that negative 10 to get negative 5. So I'm just going to shade this negative 10, and half of negative 10 is negative 5. I'm going to write that right here. We're going to bring back down this positive 25, so positive 25 comes here. And then we are always going to subtract this number squared. So no matter if this is positive or negative, we're always going to subtract this number squared. So I'm going to write the subtraction sign, and we're going to have 5 squared. So now we're going to have x take away 5 in brackets squared, and we're going to have plus 25 take away 5 squared, which is 25. And 25 take away 25 is 0. So we're going to have x take away 5 in brackets squared. So 0 is nothing, so we don't have to write anything. 25 take away 25 is 0, so we write nothing here. So now this is completing the square. And I'd just like to point out, if we change the sign on this number here, this negative 5, and change it to positive 5, that'll be x component of our turning point. And the number that's supposed to be out here, which will be 0, will be the y component of our turning point. So I'll just write down turning point. Now the question didn't ask for this, but I'm just highlighting this. All right, would be positive 5 and 0. So that's 5 on the x and 0 on the y. So we change the sign on this number here to get positive 5, and then outside here is 0, so that's the y component of the turning point. And as we know, the number in front x squared is positive, meaning positive 1. So the graph for this quadratic is a parabola, and that parabola would be a minimum curve. So for part B, we have hence solved this quadratic equation. Now, yes, you can use the quadratic formula or factorization, but because it's a hence solve and part A asks you to complete the square, you would not get any marks if you use factorization, the quadratic formula. You have to continue from this point and solve this quadratic equation. So if this x squared take away 10x plus 25 is the same as x take away 5 in brackets squared, when you put x squared take away 10x plus 25 is equal to 0, is the same as putting this x take away 5 in brackets squared is equal to 0. So I'm going to write for part B, we're going to write the x squared take away 10x plus 25 is equal to 0. So that's going to mean x take away 5 in brackets squared is equal to 0. So now the first thing you must do here is get rid of the square sign. So we'll have to take square root of both sides of the equal sign. So if we take square root of this side, it will cancel the square. So we'll get x take away 5. And if we take the square root of the 0, we'd have to have the plus or minus square root of 0. And of course, square root of 0 is 0, and 0 is neither positive or negative. So x take away 5 is just equal to 0. We carry across the negative 5, and we get x is equal to positive 5. And this would be our solution to our quadratic equation. Now, I'd just like to point out something. In a previous video, I told you the y-intercept was when x is equal to 0. That's how you get the y-intercept. Now, when y is equal to 0, that's how you get the x-intercept. So look at this. So I'm going to put note. If I had y was equal to x squared take away 10x plus 25, for the x-intercepts, we're going to put y is equal to 0. So that means putting y here equal to 0. So we're going to have 0 is equal to x squared take away 10x plus 25. All right, which is the same as writing x squared take away 10x plus 25 is equal to 0, which is the same as what we have here. And the answer that we got was x is equal to 5. So it means the answer for this is x is equal to 5. Now, what does that mean? It means when y is equal to 0, x is equal to 5. So as a coordinate, that would be 5 on the x and 0 on the y. And this is what you call the x-intercept on the graph. Now notice the turning point and the x-intercept are the same. So that means when the graph turns, it's going to touch the x-axis. And of course, this graph is a minimum. And we know this number here is going to be the y-intercept. So the y-intercept is 25. And we know we get the y-intercept when x is equal to 0. So if you had y is equal to x squared, take away 10x plus 25, and you replace the x's with 0, this will be 0, negative 10 times 0, 0, and you remain with 25. So 0 on the x, 25 on the y will be the y-intercept. So here I brought a diagram of the graph to show what the parabola will look like. So you see it's going down like a valley. So it's a minimum curve. It turns at the coordinate 5, 0. So that's 5 on the x, 0 on the y, which happens to be an x-intercept where the graph touches the x-axis. And you can see up here, it touches the y-axis at 0, 25. So 25 is the y-intercept. Now in the last video where we completed the square, we discussed the general shape of the parabola, whether it's a minimum or maximum, and the turning points, how to get the coordinates at the turning points, and of course the coordinates for the y-intercept. Now this time we are discussing how to solve the quadratic equation using the method of completing the square. And when we get the answers for the quadratic equations, those x values would be the x-intercepts on the graph, which will be where the graph touches the x-axis. Now I'd like to discuss one more thing. What is the domain and the range for the graph? Now we know the domain will be the x values and the range will be the y values. Now if you look at this graph, it starts at 5 on the x-axis. As we go to the left-hand side, it keeps getting smaller and smaller, means the x values keep getting smaller and smaller. Obviously, we'll go across to the negative side and keeps getting smaller and smaller, which means going towards negative infinity. And if you go to the right-hand side of the graph, it keeps getting bigger and bigger on the x-axis, meaning going this way, getting bigger and bigger. And we'll be going towards positive infinity as we move towards the right. So as we go towards the left, we're going to negative infinity. As we go towards the right, we're going to positive infinity on the x-axis. So that will mean the domain will be all the real numbers because they're going to negative infinity as you go to the left and positive infinity as you go to the right. So my domain will be such that x is a member of real numbers. All right, so that means from negative infinity to positive infinity, all the real numbers. Now, my range would be the y values. Now, notice the vertical distance for the graph has a limit. As it goes up this way, it goes to infinity, so it goes into positive infinity as we go up. But as we're coming down, it has a limit, which is here. So that's why the graph has a minimum value, and that's why I call the curve a minimum curve. And the y value for your turning point being 0, see the y value 0 for your turning point, is the minimum value of y. So you see how things are connecting and making sense now? It's a minimum curve because this is the minimum value of y being 0 here, and this will be the lower limit for the graph. So far, we have no upper limit for the graph. In another video, we'll go through when I give a specific domain, how we're going to get a specific range for that domain. But for now, the domain is all the real numbers, and with all the real numbers available to us, this graph will go to positive infinity as we go up, but as we go down, it stops at 0. So 0 is the minimum value of y, and what we'll write for our range is such that y is greater than or equal to 0. Because we're going from 0, go up. So greater than or equal to 0, that's going up. Okay, let's look at the y-axis here and see that, right? 0 on the y-axis is where we start, and we're just going up to positive infinity. You keep going up and up. Now for my second question, I'm going to write this 2x squared, take away 2x, take away 12 in the form a, open brackets, x plus h, close brackets, squared, plus k. And for part b, we're going to hence solve the quadratic. So starting with part a, I'm going to write my 2x squared, take away 2x, take away 12. So as we know, to use the method that I use, I need to get this x squared by itself, which means I have to get rid of this 2. So how do I do that? I factor out the 2. So I'm going to divide all my terms by positive 2. So I'm going to put 2 open brackets. I'm going to divide this 2x squared with this 2 and get x squared. I'm going to divide this negative 2x with positive 2. And I'll get negative 1x. And I'll write it 1, so negative 1x. And now I'll divide this negative 12 with this positive 2 and get negative 6. Close brackets. So I'm going to write back this 2, open brackets. So now I'm going to put my brackets for my perfect square. My variable is x. I write back x. I'm going to find half of this -1, which would just be -1/2. So a half of -1 would be -1/2. Then I'm going to bring back down the -6, and I'm always going to take away this number squared. So that'll be 1/2 squared. So now close brackets. So I'm going to have 2 open brackets. This part here is good. I just need to work out what is -6 take away 1/2 squared. So now with lower indices, we have to square both the numerator and the denominator. So I have 1 squared over 2 squared. 1 squared is 1, 2 squared is 4. So I'm going to get 1/4. So now we notice -6 take away 1/4. Two signs are the same, so you're going to add and keep the negative sign. So adding 6 1/4 is just 6 1/4. So I'm just going to write that here. -6 take away 1/4 is simply -6 1/4. But I would need this as an improper fraction because I know I have to multiply everything by 2. So I'll need this as an improper fraction. So let's convert that one time. So 6 by 4 is 24 plus 1. So that's 25 over 4. So what I'll write is 2 open brackets, x take away 2 close brackets squared. And I'll write, of course, this was negative because -6 1/4. So that'll be -25 over 4. So we're going to have -25 over 4. Close brackets. So now, when I multiply this 2 by this here, I cannot multiply 2 by x and 2 by 1/2 because the square sign preventing us from doing that. So I have to write back 2 open brackets, x take away 1/2, close brackets squared. And now when I multiply the 2 by -25 over 4, what I'll get is -25 over 4 multiplied by 2, which is 2 over 1. So 2 into 2, 1, 2 into 4, 2. So that's going to give you -25 over 2. So here I'm going to get -25 over 2. Now let's convert this to a mixed number. So we're going to have 2 open brackets, take away 1/2, close brackets squared, take away. And of course, 2 could go into 25 12 times because 2 by 12 is 24. So we're going to get a remainder 1. So that'll be 12 remainder 1 over 2. So 12.5. So I'll just like to note that our turning point, all right, would be change the sign on this -1/2 and get +1/2. And that'll be x component to a turning point. And of course, the y component will be -12.5. So -12.5. In decimal form, that will be 0.5 and -12.5. So now for part B, hence solve this quadratic. Now we already complete the square, the same quadratic, we complete the square. So we put this quadratic in this form. And now we say in the same quadratic is equal to 0. So now what I do is put this form equal to 0 and solve. So I'm going to, for part B, we have 2x squared, take away 2x, take away 12 is equal to 0. So that means the same as putting this here equal to 0. Now, to solve this, I'll prefer the version with the improper fraction rather than the mixed number. So I'm going to write this line here. I'm going to use the -25 over 2. So I'll write 2 open brackets, x take away 1/2, close brackets squared, take away 25 over 2 is equal to 0. So now the first thing I'll have to do is move this -25 over 2 across the equal sign. I will turn to +25 over 2. So I'll have 2 open brackets, x take away 1/2, close bracket squared is equal to +25 over 2. Then the next thing I have to do is I can't manipulate anything inside of here because of the square sign. So this fixed until I deal with the square sign. So what I have to do is move this 2. So this is 2 multiplied by what's in brackets here. So the operation between this 2 and this is multiplication. So when I transfer the 2 across the equal sign, the operation will change to division. So what I'll have is x take away 1/2, close bracket squared, is equal to 25 over 2 divided by 2. Now if you divide by 2 is the same as multiplying by 1/2, or what we say is convert the divide to multiply and invert your divisor. So we have x take away 1/2, close bracket squared, is equal to 25 over 2 change the divide to multiply, and this is 2 over 1, so you invert it and get 1 over 2. Now, of course, these two denominators, we multiply them and get 4 because nothing would cancel. All right, so 25 by 1 is 25 and 2 by 2 is 4. So we're going to have x take away a half in brackets squared is equal to 25 over 4. So now, to get rid of this square, we have to take the plus or minus square root on this side. So we're going to have x take away a half. Basically, we're taking this plus or minus square root on both sides, right? So you're going to have plus or minus the square root of 25 over 4. So when you take the square root on this side, it cancels with the square. So that's why I get the x take away a half. And of course, you take the square root on this side. When you do to one side of the equal sign, you must do to the other side of the equal sign. So now this is going to look like this. X take away a half is equal to plus or minus the square root of 25 over the square root of 4. And the square root of 25 is 5, and the square root of 4 is 2. So you're going to have x take away a half is equal to plus or minus 5 over 2. So now what I'm going to do is transfer the negative half across the equal sign. I'm going to turn to positive a half. Now, yes, you can write the positive a half after the 5 over 2, the plus or minus 5 over 2. But it looks better when you put it in front when you have the plus or minus sign. So I'm going to have x is equal to positive a half plus or minus the 5 over 2. So now I need to go and work out this to get my answers. So I'm just going to go to the next page. I'll write back my questions. I'll put part B. All right, so this is my quadratic equal to 0. And what I got was x is equal to a half plus or minus 5 over 2. So now what I'm going to say is either x is equal to a half and use one of the signs, so plus 5 over 2, or x is equal to a half take away 5 over 2. So that's how we use the plus or minus, right? So one of them is plus, so a half plus 5 over 2, and the other one would be a half take away 5 over 2. Now, seeing that the denominators are the same, I can just deal with the numerator. So 1 plus 5 is 6, and 1 take away 5 is negative 4. So I'm going to get x is equal to, as I say, 1 plus 5 is 6, so that's 6 over 2, which is just equal to 3. And for here, we'll have 1 take away 5 is negative 4, and put that over 2. So that's equal to negative 2. So the question is completed, but now is for the extras. So as I said, the answers to solving the quadratic would be x-intercepts on the graph. So I'm going to have note, all right, if I had y is equal to 2x squared, take away 2x, take away 12 to draw the graph, you'll put 4 x-intercepts, y is equal to 0, which will mean putting this equal to 0 because y is 0, which will mean 2x squared take away 2x take away 12 is equal to 0. And as you know, we got the answers x is equal to 3 and x is equal to negative 2, which simply means as a coordinate, x is 3 when y is 0. Because how do you get this 3 when y was equal to 0? And of course, on the other side, we'll have negative 2 and 0. And these will be your x-intercepts on the graph. And that will be where your graph touches the x-axis. Now, for the y-intercept, I'll just demonstrate it here again. So now I'm going to put for the y-intercept, x is equal to 0. So if I write y is equal to 2x squared, my quadratic again, and I put the x is equal to 0, well, you can see that this will give 0, this will give 0, and the only thing will remain is negative 12. So we're going to get y is negative 12. So we got this negative 12 when x is equal to 0. So as a coordinate, you're putting the x first, which is 0, and then the y is negative 12. And this is your y-intercept. So we have the x-intercepts, we have the y-intercept, and here we have the turning point being a half and negative 12 and a half. So now we can look at what the graph would look like. Of course, the number in front of x squared is a positive number, so it's going to be a minimum curve. So if we look at the graph, it's a minimum curve because the number in front of x squared is positive. We see our answers for quadratic being negative 2 and 3. See, negative 2 and 3. Those are where the graph touches the x-axis, the x-intercepts on the graph. We've seen the y-intercept being negative 12, which we worked out here. Y-intercept is negative 12, 0 on the x, negative 12 on the y. That's here. And if you go on to the other page, our turning point are half and negative 12 and a half. And a half is 0.5, and negative 12 and a half is negative 12.5. So we see that here, 0.5 and negative 12.5 as our turning point here. So we want to discuss one more thing, which is the range and domain of this curve. Now the range is the y values and the domain is the x values. Now let's start with the domain first. So we're looking at the x-axis for the domain. As this graph keeps going up on both sides, right side and left side, it keeps getting wider, which means it's going more to the right, which is getting greater and greater on the x-axis, and more to the left, which is getting less and less on the x-axis. So getting less and less on the x-axis is going towards negative infinity, and going more and more on the x-axis is going towards positive infinity. So essentially, x values for this graph will be all your real numbers, because this graph has no upper limit. It keeps going up and up, but it does have a lower limit. So we'll talk about that when we deal with the range. So as it goes up and up on both sides, it will encompass all the x values. So for our domain, we'll write x is a member of real numbers. So I'll have for my domain is such that x is a member of real numbers. And for my range, it'll be such that if we look, as I said, the graph has no upper bound, but as we go down, there's a lower bound, and that's why the curve is a minimum curve, and that's why this negative 12 and a half here on the y-axis is the lower limit for the graph. That's why I call it a minimum. So when you say find the max or min value of y, that's what we're talking about. This is the minimum value of y here, negative 12 and a half, because that's the lowest point on the graph. So it has a lower bound. So this graph goes from negative 12.5 on the y-axis and up, which is greater than or equal to negative 12.5 or negative 12 and a half. So for my range, I'm going to put y is greater than or equal to negative 12 and a half. And of course, you could put where y is a member of real numbers as well, but of course, it's not all the real numbers. It's just from negative 12 and a half go up. All right, so for my last question, I'm going to give you a maximum curve. So we have negative 3 in front of the x squared. So we're going to complete the square on this quadratic, and then we're going to proceed and solve the quadratic. So for part A, I'm going to write my quadratic, negative 3x squared plus 6x plus 24. So to use the method that I use, I'll have to get rid of this negative 3 that's in front of the x squared, and I'll do so by factoring out the negative 3, which means divide every term in my quadratic by negative 3. So I'll have negative 3, open brackets, divide negative 3x squared by negative 3, and I'll get positive x squared. Divide positive 6x by negative 3, and I'll get negative 2x. Divide negative 24 by negative 3, and I'll get negative 8. Close my brackets. So now I'll write back in negative 3, open brackets. I'll put my brackets for my perfect square. And I know I'm bringing back down to negative 8, so I can write negative 8 here one time. All right, so my variable is x, so I put x. So then I'll find half of this number here, which is half of the coefficient of x. So a half of negative 2, that will be negative 1. And I'm always going to take away this number squared. So that'll be negative 1 squared. So now close my brackets. So I write back my negative 3, open brackets. This part here is good. X take away 1 in brackets squared. Now I need to work out what is 1 squared, which is just 1. So take away 1. And now I just need to work out this part here. So two signs are the same. So that's how I add and keep the negative sign. So 8 plus 1 is 9. So I'm going to get negative 3, open brackets. X take away 1 in brackets squared. And I get negative 8 take away 1 is negative 9. Close brackets. So now to get rid of this big brackets, I'll multiply these two things by this negative 3. So when I multiply negative 3 by this here, I can't multiply the negative 3 by the x sign negative 1 because of the square sign. So what I'll write is negative 3, open brackets, x take away 1, close brackets squared. And when I multiply negative 3 by negative 9, what I'll get is negative 3 by negative 9, two negatives, you get positive. And 3 by 9 is 27, so that's positive 27. So now here we have completed the square. But let's like to note what our turning point would be. So I'm just going to put note, my turning point would be for the x component to change the sign on this number here. So from -1, we'll turn to +1. And the y component will be this +27. So now for part B, hence solve this quadratic being equal to 0. So I'll put for part B, we have -3x squared plus 6x plus 24 is equal to 0. And if we put in this quadratic being equal to 0, when we change the form of this quadratic, we got this. So these two are the same, just in different forms. So I'll just replace this quadratic with this form with the perfect square. So I'll have -3, open brackets, x take away 1, close brackets, squared, plus 27 is equal to 0. So now the first thing I'll do is transfer the +27 across the equal sign. I will turn to -27. Then I cannot touch inside of here until I deal with the square sign. So I'll have to transfer the -3 across the equal sign. And of course, it's -3 multiplied by the thing in brackets. So when it goes across, the operation will change to division. So I'll have x take away 1 bracket squared is equal to -27 divided by -3. So I'm going to have x take away 1 in brackets squared is equal to, obviously, divide two negatives, you get positive, and 27 divided by 3 is 9. So I'm going to get +9. And now, to get rid of the square sign, I'll take square root on both sides. So square root on this side will cancel the square. So I'll have x take away 1 is equal to, I'm going to take the square root on this side, it'll be plus or minus square root of 9. So x take away 1 is equal to plus or minus, well, square root of 9 is 3. So when I transfer this 1 across the equal sign, it'll turn to +1 and I write it in front here. So I'll have x is equal to +1 plus or minus 3. Now it's easy to see answer there. All right, we'll have either x is equal to 1 plus 3 or x is equal to 1 take away 3. And that's why you use the plus or minus, 1 plus 3 or 1 take away 3. So 1 plus 3 is 4, and 1 take away 3 is -2. And now remember what I told you, the answers to your quadratic would be your x-intercepts on the graph. Now I know the question done here, but this is the extras. All right, so these are the x-intercepts on the graph. All right, so I'm just going to put notes. X-intercepts. All right, that'll be 4 and 0. And then we have -2 and 0. Those are my x-intercepts. And then the y-intercept would just be this number here, because you're going to put x is equal to 0. So this part will be out and remain 24. So 0 on the x and 24 on the y. So now we have everything to draw the graph. We have the y-intercept, the x-intercept, and the turning point. All right, so we go to the next page and see what the graph looks like. All right, so here you can see our function is -3x squared plus 6x plus 24. Of course, the number in front of x squared is -3, so that means the graph is a maximum curve. It means it's going up like a mountain. And you can see that here. Our x-intercepts, which will be the solution to our quadratic. So if you look back here, we are seeing that the solution to the quadratic was 4 and -2. So if you look on the graph, we see that -2 and at +4 is where the graph touches the x-axis. That's why we have these coordinates as our x-intercept. Our y-intercept is the 0, 24, or touches the y-axis at 24. Because our constant here is 24, we know that will be the y-intercept. That's why we are 24 here. And of course, our turning point is 127, which we had here, 127. Change the sign on this number, and of course, 27 is the y component. So x component, y component. So now let's discuss the range and domain here. Now, from this point, as the graph goes downwards, it will keep getting wider and wider. So again, the line will move to the right, which is getting greater and greater on the x-axis. And this will keep moving to the left, which will get less and less on the x-axis. So it's still going towards -infinity this way and +infinity this way, starting from this point here, 1. So the domain going to be those x values, which will be all your real numbers. All right, so my domain is such that x is a member of real numbers. And my range will be such that, well, there's no lower limit to my graph, but there is an upper limit. And that's why it's called a maximum curve, because the upper limit is this 27. So this y value of 27, which will be here, will be the highest point on the graph. And that's why it's a maximum curve. So when I'm writing my range now, I understand that the graph has no lower limit, but it has an upper limit. So it's going to be less than 27. The y values is from 27 go down, so less than or equal to 27. So I'm going to put my y is less than or equal to 27. I can put where y is a member of real numbers. So it's not all the real numbers, but it's just the real numbers that's less than or equal to 27. And that will bring us to the end of this video.